Yes, so let's start with a very formal introduction. What are we gonna have in this module? Though you might already be aware, but there are some participants who joined for the very first time. Okay, so see, the the very first track here is always CCNA, and then people
Yes.
get sorry.
Okay, I'm there, Sagar now.
Okay, okay, sure, sure. So we start with usually CCNA, then we go to CCNP, and then we go to the expert level. This is the hierarchical order we follow. Now, prior to 2020, there used to be a lot of different domains here: RS, security, wireless, ISP, so and so thing. And then people used to get into the same track, and same used to happen when they go into the expert level. Okay, there used to be at least 6 to 7 different variant of CCNA, the different variants of CCNP, and so on. But now these things have been revised. You don't find all those things as of now. You have only a single paper for CCNA, which is again not a prerequisite for CCNP. And over CCNP, the R&S is replaced with enterprise, and then you have security and the rest of paper as it is, like DC, service provider, wireless, and nowadays you also have a DevNet. And someone who is CCNP SEC certified, okay, someone who is now CCNP SEC certified, he would be definitely willing to be entering into CCI security. Okay, CCNA is not a prerequisite. Remember that. It used to be previously when we used to do CCNA first. CCNA might be CCNA SEC, then CCNP SEC, or then we used to climb directly to CCI SEC, or we used to the two papers of here. There was a paper called written, and there used to be paper of lab 8 hours, right? But this format has now changed. We don't follow this format. Now the format is a bit different. The format is you can start straight away with CCNP security. So there is a mandatory paper here which is called as ESCO. So this paper act as a written paper for CCI security lab as well as for CCNP as well. CCNP mandatory paper. And once people have completed with the ESCO paper, they have two options. Either they can go towards CCI SEC and then appear for the 8 hours of lab, so that written plus lab they become CCI certified. Or if you still are not very much prepared for CCI, you have a different concentration paper here. So you have a paper for VPN, you have a paper for ASAFTD, which is called Next Gen Firewalls. You have a email security appliance, the web security appliance. You have one paper from the automation point of view. You have a Cisco ICE. So this is the pattern now. So someone who has done CCNP score paper, written paper, he can either get into CCI lab and get that magic number, or if he thinks that he is not well prepared for CCI SEC, then he can try to be a specialist in one of the security technology. If he wants to be a specialist in VPN, he can definitely attempt this paper. So all the CCNP level papers are usually MCQ based questions. So a very regular pattern, 90 minutes of duration. There would be 100 to 120 MCQ questions. and out of four you select one, out of four you select two. Sometimes it would be drag and drop, right? That kind of pattern it is. But CCI lab 8 hour, that's a combination of both, basically MCQ and task based. So we'll talk about the two patterns now. So when I put CCNP, and on the other side we have CCI. So what all paper from the security point of we are covering in CCNP? We have S-Core, which is a written paper. And from the CCI, it would be the lab paper, which is a 8 hours paper, which is again divided into two blocks. So there is a design, which consists of 3 hours, and there is a DOO, deployment, operate, optimize, which is 5 hours. Now this is MCQ based. Design is completely MCQ based, whereas the do paper is completely task oriented. Task could be optimization, okay, could be troubleshoot, whatsoever it is. So this is completely task based. The tickets are given, you go fix it, you go and configure it. So that's a part of lab. And score as well as is a MCQ based. So this is a written paper and this is a lab paper. Now in the lab, you need to have knowledge on multiple technology. So what type of technologies are we expecting in the CCI security? We are expecting task based out of ASA, firepower, Cisco ICE. There is one task from the DNAC perspective, then ESA, WSA, firepower. Sorry, yeah, I have already written firepower, so I can say that AMP, anti-malware protection. So these are some technologies based out of which you will receive multiple tasks, at least 20 to 25 tasks in the 5 hours of window. Now, this we cannot directly start in the CCI level. That's why this batch that we are conducting here in Network Journey, we will be going in a block by block. So let's say score is one of them. Then what do we have next? Let's say we have the VPN paper from the CCNP concentration paper, which is SVPN. It's 300701. The exam code for that is okay. So I'm going to write 300730. This is the exam code. What else we are gonna have it? We have ASA firepower, which is part of next gen firewalls, and this is going to be let's say 300710. Then we have Cisco ICE, which would be 300715. Then we have ESA, WSA, which is going to be 300720 and 300725. So these are different concentration paper. You don't have to write each one of them. As I told you, if your target is to write the CCI, then you need to clear the written paper and then jump into the lab preparation. But the lab consists of this many technologies, right? So you need to know some knowledge on it. So we would be covering block by block. We will be first going with ASA firepower, then we cover ICE, then might be we cover a ESA, WSA, then we cover VPN. So what are we starting in this in the current module? In the current module, we would be covering, or we would be starting with SVPN now. Okay, one of the topic from the security point where you will expect at least 4 to 5 questions in your lab task, okay, of which is of 5 hours. you will expect at least a 4 to 5 different questions. So what type of different tasks would you be expecting here? The SVPN, from the SVPN module, you will expect 4 to 5 questions in your CCI Security main lab exam. Okay. So what are the different tasks that you would be expecting from this module? Something coming from remote access VPN, could be IPsec, could be a flex VPN, it could be anything like DM VPN. So, as the name suggests, SVPN, you would be going through multiple types of VPN in this particular module. So, let me show you the course content of SVPN. So, first, let's go to the training and certification. So, let's go to security. Yeah, so you have score, you have next gen firewalls, you have the firepower, Cisco I, Cisco email security appliance, web security, SVPN. So let me open the SVPN here. So this is SVPN. And if you click on the lab outlines, so you can see here the objective of this module is site to site remote access. What are the different lab outline you would be expecting? We would be making a point-to-point VPN. We would be configuring a VPN between Cisco ASA point-to-point VPN. We would be making use of the VTY tunnel interface for different types of VPNs, like Flex VPN, etc. So we will be discussing about DM VPN. So these are all Flex VPNs, different type of Flex VPNs, troubleshoot of it, any connect. This is for remote access. So these are some of the course outline, the lab outline for the SVPN point of view. Okay, so to get started, we need to start from certain point. Let me also show you a much better outline for SVPN. So this is the 300.730 version 1.1. If you click on this, you receive the PDF covering all the topics. So it's a site to site, first chapter. Then we have remote access. Then we troubleshoot via ASDM and CLI. We have secure communication architecture, the design site to site VPN, design remote access VPN, and the algorithms of this. So this is about SVPN topic, which is part of your CCI Security version 6.1. So if you go into CCI Security version 6.1, so if you come here, you can see that this is what the blueprint for CCI Security. And this is gonna contain all the VPNs that you need from the lab point of view. So you have remote access. So basically, when we are covering multiple modules by module, the level of knowledge that you would be gaining for your final exam would be helpful. Okay, rather than just coming over to this blueprint and just performing one small lab. When you go via multiple things, you are gaining multiple knowledges, which will help you in the later on part. Okay, So this was a bit about the course blueprint and what are we going to cover. So as I told, this would be starting with SVPN topic 300730 version 1.1, which is the latest version now. And regarding to the welcome kit, I'll come in some time. I'll come back and I'll just guide you. But first, let's have some technical discussion. So, have you guys heard about VPN ever? Do you know what is the?
Yes, your screen is not only the Cisco screen is coming now.
Okay,
Notepad screen is coming. Okay, sir. Okay, got it.
okay. So, have you heard
Yeah,
about
we
VPN?
had. Yeah, we had a VPN. We heard about the VPN.
Okay, great. So, what does this VPN does?
A secure tunnel between the untrusted network zones, like from like working from home or connecting a different business sites. So whatever our traffic is there, it is going in a secure channel, secure
Okay.
tunnel. Sorry.
Okay, so it is going in a secure channel over on certain protocol, over on certain encryption format, so that no one in the internet can break through our packet and steal through the data, right? So that's basically how you're securing the tunnel. So we will discuss about different types of VPNs. Now you can classify them in various way. If you classify them on basis of a tunneling protocol, you have MPLS, you have point to point, you have layer 2 tunneling protocol, you have SSL TLS, which is a layer 7 protocol. You also have IPsec. So these are basis on the tunneling protocol. If you
There is one
classify
more side to side VPN also we heard about. What
site
it?
site to site is not tunneling protocol. It's in a different when I come into different mode, then I'll talk about site to site.
Okay, okay. Thank you, thank
Right now IPsec is what is the tunneling protocol that is making use in the site to site. Okay, when you go on a level of security concept, you can break a VPN in two terms. One, you can call it as a most secured VPN. Example is site to site, Flex VPN, right? Might be GRE plus IPsec. These are secured ones. You can also have heard about something called less secured VPN. That is like only GRE, or let's say if you go with a web SSL based VPNs. So these are some less secured VPNs. This is in terms of security context. If you go from the basis of implementation, if you're implementing a VPN, so you can also have it in two different ways. You can have in terms of hardware VPN, where you need a physical boxes to deploy, or you can have a software based VPNs. Okay, where you do not need any hardware, you can just do it in a web to web basis. Whereas here you might need a ASA box. If you are a Palo Alto, you might need a Palo Alto device or a FortiGate device. But here you have two applications and you are building a VPN tunnel between two application based. There is no a physical device involved. So this is based on implementation. If you think about from the use case, if someone is talking about from a use cases, you can think from business perspective, a business VPN. You can think about from a personal VPN concept. Personal is like what you have at your home. Might be you're using a open sourced like open VPN kind of protocol, whereas for business you are having a ASA firewall, and on the other side you have a Palo Alto. So that's a business, and also at the same time a mobile VPN. So nowadays over on the mobile as well you can configure VPN to connect your office network or etc. So this is based on the use cases. What next? Let's say from the network architecture. On the basis of network architecture, how can you divide your types of VPNs? Like you have intranet, you have extranet VPNs. Intranet VPNs are basically for your internal organization. Let's say you have employee 1, employee 2, and they have to transfer a file. They have to let's say access a OTP server, so it's within the internal. So it's an intranet VPN. Extranet in the sense, let's say you're selling your softwares to customers, and they are connecting to your product or to your servers that is hosting them. So that's an extranet VPN. Based on technology as well, you can divide them. So based on technology in the sense, MPLS, IPsec. So these are some technology based VPNs, MPLS, IPsec. You can also divide them in terms of OSI layer. If you have heard about OSI layer starting with layer 1 till layer
Yes.
7. So layer 1 is physical layer. We do not have need of VPN because this is more like the transmission where all this T1, T2, E1, E2 links are being discussed. So we are not much involved VPN at this point. But from the layer 2 perspective, if you have heard about Ethernet VPNs, you have frame relays. They are all layer 2. Frame relays or ATM, asynchronous transfer mode. There is also a layer 2, layer layer 2.5 VPN, which is MPLS VPNs. The MPLS considered as a layer 2.5. When you go to layer 3, you have the network layer included, and all this IPsec, which is IP address 50. Then the so basically these are few of them which comes under the layer 3, the IPsec, which you use in the site to site. When you go to layer 7, sorry, layer 4, you have the SSL TLS.
Sagar, can you repeat layer 3 VPN, layer 3?
Layer 3 is based on network layer. So you have an example for that, IPsec.
Okay, okay.
Okay. In the layer 4 classification, you can think about the SSL TLS based VPNs. In the layer 5, you do not have any directly, because this is a presentation layer, so you do not have any VPNs directly, but it's involved in third and fourth and seventh. So basically it comes into picture. So
Hi, Sagar. Sorry to interrupt you. Layer 4 VPN, which is says SSL TLS, which is like connected through the browser. Is that one?
yes, it is connected via browser.
Okay.
It
And
can
what
be
about the
via
Ethernet
browser.
VPN? Are they in used anywhere currently?
Which one?
Ethernet VPN layer 2?
No, these are not very much used these days.
Yeah, because Ethernet VPN I never heard before, so it's new.
Yeah, those are not very much utilized nowadays because we have the advanced version like MPLS we can use or DM VPN we can use. Okay, so layer 5 is session layer. So session layer and layer 6, which is presentation layer, they don't directly have any VPN, but since there is 3 and 4 and 7, so we basically can just rule out that. And under layer 7, you can think about all your other examples like mobile VPNs and SSL, TLS, or remote access. So these are all part of layer 7 VPNs. Okay. So just let me repeat. We discussed about types of VPN, which can be classified on different bases. So if we talk about tunneling protocol, we have a list of it. If we talk about security, we have secured and less secured. If we talk about implementation, we have hardware based and software based. If we talk about use cases, we have business plan, business VPN, personal VPN, and mobile VPN. If we talk about network architecture, intranet and extranet. If we talk about technology, we have MPLS, IPsec, Flex VPN, all those DM VPN, Get VPN, etc. If you talk about from the OSI layer, we have written the examples for most of these layers, starting with layer 2, layer 3, layer 4, layer 7. We have one or two VPNs which can be kept in each one of them. Okay. So this is from the different classification. But what happens is we most of the time we only are aware of the popular VPN terminologies. That's all. We don't actually go into that deep that what bases they are exactly, but we always hear the popular VPNs. So under popular VPNs, we have the remote access type. This usually are two type. You have a web based and you have that client based. So I'm gonna put this as application based. Like for example, AnyConnect. Similar way, one more popular name that you might have heard is site-to-site VPNs. Right now, here comes all that IPsec and IKE, etc. Uh, Site-to-site can be of two type. You have a policy based or access list based as well. So policy based and access list based. There's also more details about this, which I'll tell you in later classes, the different protocol, encryption, etc. Then you have something called IPsec VPN, or you can just call it as IPsec, because this is a encapsulation which can be used with GRE. You can use this with Flex VPN. So this is one sort of a framework which you can use with another type of VPN to secure them. Okay, so IPsec VPN, you have SSL TLS, which I've already mentioned in the remote access, so there's no need of mentioning again. You have MPLS VPN, though this is not much in the CCI sec because this is a part of ISP service provider. You have Open VPN, but again, not from the CCI sec. This is a open sourced, but we use this especially in a home requirement to build or to access our laptops or whatsoever it is. Okay. Then we have DMVPN, dynamic multi-point virtual private network. We have Flex VPN, which comprises of IK version 2 and it runs over on 15.x. or A say operating system, anything about 8.4. Okay, so this is something which is a short form or is a simplified form of an IPsec type of VPN. So
So,
yeah.
so excuse me, just a question. MPLS VPN, you said it's ISP VPN. Is it not Get VPN?
No, Get VPN is another type of which I was about to write here. Okay, the difference here is this is a tunnel-less VPN.
Hmm?
Okay, whereas this is a type of hub and spoke, but it makes use of a tunnel interfaces to break through.
Okay, because I may be wrong. What I heard is that MPLS on its own is not secure. So if you have MPLS and you're going to run a kind of security on it, because MPLS is a VPN, that's what I heard. But if you kind of securing it, you're going to use Get VPN on top.
Yes, correct. We can use multiple of them in a combination. I can use them with IPsec, or I can use in correlation with a Get VPN. You can also have, let's say, GRE, which is less secure, but you can make use of it along with IPsec.
Okay.
Okay, so these are some of the VPNs which are very popular, like remote access, site to site, SSL, TLS, MPLS, Get VPN, Flex, DM VPN, GRE plus IPsec. Okay, so I have just put down the different names here, a short brief on the classification. Okay, so it's okay. Let me have one simple topic which is called CI triad. This used to be earlier in a CCNA CCNA Security, but since now you don't have CCNA Security, this has been added in the CCNP Sec itself. Okay, so as per CIA model, which stands for confidentiality, integrity, and availability. Okay, so this is something what we expect from a. Okay, 1 second. Yeah, from a VPN point of view. So let's say if this is branch A and you have branch B, and you are passing on the traffic over on internet, a shared infrastructure. Now, how do you secure the traffic? How do you secure the traffic between branch A and branch B? You have various options. You can deploy point to point, you can deploy MPLS, etc., but they could be cost effective. So the simplest and the least time concerned would be to have a VPN constructed, a site to site type of VPN or a remote VPN, right? So you can construct a VPN on top of a shared infrastructure. Now, what happens is when you are sending out the packets over on this, you only allow these two nodes to decapsulate them. Okay, they will encapsulate and decapsulate, but rest over in the shared infrastructure, there should not be any way someone can decode or decapsulate. So you would be making use of certain algorithms, encryption, to encrypt the packet, encapsulate the packet, which would be shared across the internet. And on the other side, the receiving side, they will decapsulate, they will take out the headers, all the encryption integrity that was added, and then the plain text is being sent across to the next host, which are in their LAN network, because they do not understand the algorithms that you have used to encapsulate here. So the encapsulation or decapsulation happens at the two termination point. So we call this as termination point. And whereas the LAN side of it would be plain text. So plain text, when you are sending it out, you will get it encrypted format, then send it. Only the receiver can decrypt and give those in a plain text to the LAN who are behind that particular receiver. So what we expect from the VPN is we have confidentiality, integrity, and availability. Confidentiality in the sense, if I'm sending a packet from branch A to branch B, it should not be manipulated, or it should not be disclosed to another person. So let's say I have a man in middle. You might have heard about man in middle attacks. So basically, someone who is trying to steal the data, open through the data to see what is the data content of that. So confidentiality in the sense, you are trying to achieve certain certain things from the VPN, that only the two nodes or the two branches can decrypt or encrypt it, and others don't. So, what are the supporting protocols that can be used here, or the supporting encryption can be used here? So, there are two types. One is called asymmetric encryption and symmetric encryption. Then, what does integrity refers to? Integrity refers to the concept where the things are not being altered. Say, for example, you sent a 20 MB of file, but when you receive it on the other side, it should not be, let's say, 18 MB or 19 MB or 21 MB. It should be exactly 20 MB. So basically, this same file should be reached on the other side. It should not be altered. It should not be, might be hard coded with the malware into them. So that is achieved using integrity, and the protocol or encryption that we use to achieve integrity is MD5, message digest, or I can go with something much more better like SHA mechanism. And the availability says, in a production, the main concept is whatever uh, branch A, branch B, you have servers behind them, they are available. They're not down due to a DOS attack or a DDoS attack. So these are the main model in the CCI or in the security domain. And this is the aspect that we expect from the VPN concept. We expect that our VPN gives us confidentiality, it gives me integrity, it gives me availability. That's the main reason why we secure the data, so that the data is are not modified, or a unauthorized person is not accessing through our data. Okay, it's called a CIA triad or CIA model. Regards to the different key topics that we put down here, like DES, 3DS, this I will take up separately. What is asymmetric, what is symmetric, what is DID certificate, RSA certificate, what is MD5, what is SHA. So this things I will take it separately. It will be too heavy if I go it on today. Okay. So clear till this point? Any question till this point? All right. So what we are gonna do now is the one of the simplest option here is IPsec VPN, which you guys might have heard about this. Okay, so there are two types that we can have it here in the IPsec. One is called site-to-site remote access VPN. You're using a VPN client or something. Now we will be in general talking about the flow, okay, irrespective of what type it is. So what happens in IPsec? What are the different modes that we see here? What are the different headers we do see here? What is the entire process of a IPsec VPN? Okay, so this is more like overview right now. So what happens in IPsec? Do you guys know about the phase 1, phase 2 things?
No, don't
Okay.
know.
So let's say the first process would be initiation. This is when the data are being triggered to send over on the tunnels. Now it could be either from this direction or it could be either from this direction. So this is the first step. In the second step, we expect it goes via certain phase construction. So we have two phases in IPsec. One is called phase 1 and the second one is called phase 2. Once the phase 1 gets completed, then it will look for phase 2 completion. Then the data would transfer over on that particular tunnel, data transfer. And if all the datas are transferred and there is no more data transfer for, let's say, certain minutes, like 30 minutes, then the VPNs will also get terminated. So this is a overview of what happens till the disconnection, starting with initiation, phase 1, then phase 2, data transfer, termination. Now there are a lot of things in each one of phase 1 and phase 2. So in the phase 1, what are the different things that we would see? Phase 1 can also be called as ICAKMP, which is an older name. Nowadays we call it as IKE, Internet Key Exchange. This stands for Internet Security Association Key Management Protocol, which was an older name. Now we call it as IKE. IKE also has two versions now, version 1 and version 2. Whereas in the phase 2, we have IPsec only. Okay, the IP suite or the different IP suite here. So this is just an overview. What are the different parameters that we see in phase 1? So we will have the hashing algorithms, as we were talking about integrity some time back. And what are the supported protocols? It would be MD5 or SHA. We have authentication. Something to deal with confidentiality. So as we were talking about the pre-shared key or digital certificate. What else? We have something for Diffie-Hellman group. Basically, Diffie-Hellman group is to determine the strength of a key. Okay, so I can go with, let's say, group of 2, which is modulus of 1024. Or I can go with group of 4, which could be 246. The more the modulus size, the more strength or more secure it would be. But in a other way, the more strength you prefer, the more resource utilization it would take for the device to encrypt and decrypt. So between branch 1 and branch 2, let's say you are keeping a very secured mechanism, let's say 4196, and you have 4196 here. So the overhead is also increasing on those devices to encrypt and decrypt. If you go with a simplest option, let's say 1024 and 1024, might be it is taking a less time and less resource utilization on the devices. So the more you go, the more security you might receive, but it is also be impacting that overhead on the devices to encrypt and decrypt. Okay. Anyway, that's about the Diffie-Hellman life timer, which you can define in seconds, and the encryption methods like DES, 3DS, AES. So these are some parameters that we expect in the phase 1. This is the first step which has to be completed. Then it goes to the second phase. And in the second phase also, you have certain parameters needed. You have to define the IPsec protocol, whether authentication header or encapsulation security payload. By default, this is enabled. But if you need less secure, then you can go with AH as well. So in the case of DM VPNs, we have AH, and in the case of site-to-site VPNs and Flex VPN, by default, it will take ESP. We need to define the encapsulation mode. There are again two types: transport and tunnel. So tunnel is when you need encryption, integrity, and the complete packet to be secured. But in the case of transport, you don't get the complete packet being encapsulated. You don't get the complete security, right? It's a let's secure thing. So it depends on your requirement, what you need, and you can select accordingly. Then, as usual, encryption, something from DES, AES, which you can take up as per the design what you are looking for. Authentication, MD5 or SHA. Lifetime, again in seconds. And DH group, if in case the vendor support. There is also something for perfect forward secrecy, PFS, which you can set certain group, PFS group 1, group 2, group 3, etc. It's again a way to strengthen up the security. Okay, so there are a lot of optional values available, which sometimes you don't have to do it, but most of the time we do with the basic changes in the terms of deciding what to go with. If I say that I would prefer going with SHA, but what, let's say 512, then make sure on the other side the administrator is configuring the same. Let's say if I have SHA 512, the other side also the administrator must configure the same SHA 12 itself. If he does a mistake here, let's say if we do a MD5 over here, then that particular phase will not come up. So we will see this while we do the technical lab. But these are the parameters that we have in phase 1 and phase 2. And yes, as I have a comment which says phase 1 happens over on control plane and phase 2 happens over on the data plane. Okay, so how does it look like is, let's say I have a branch 1, branch 2.
Sir.
Yeah, come again.
Yeah, I wanted to ask you about DH. You just mentioned. I believe DH, Diffie-Hellman.
Okay, yes.
You said on phase 2, it may or may not support DH. Does it mean in phase 2, we can configure phase 2 without DH?
Yes, in the case of phase 2, DH is
Yeah.
optional.
Okay. Why is it optional at the end of the day?
Because sometimes what happens is some vendors do not have this option at all in the phase 2. You can prefer going with PFS, or you can prefer going with DH, or you can prefer keeping them optional itself. If you have both the vendors supported, you can select them. But let's say if one vendor is supported, but if the next one is not, that's why we cannot always keep them be powered on.
This is my first time to hear about PSF. What does it do exactly?
PFS is something to do with the phase 2 key exchanges. Okay, what happens is, let's say if the datas are being getting exchanged, right? You have certain keys, but if I make use of the PFS, it basically asks them to, or force them to generate a new shared key. So it becomes more aggressive now. It becomes more aggressive where someone who is trying to crack through the packets don't get easily. Let's say someone has the packet for 1, 2, and 3, and he's trying to decode the fourth one. The PFS makes it more complicated to break through with the same pattern over here. So it's like forcing enough to generate a new shared key here.
Yeah, because what I understand is that it's on the phase 1. Please correct me if I'm wrong. Okay, guys, please. What I understand is on the phase 1. At the end of the day, we get the session key generated to be used for phase 2. Okay, so all the process on phase 1 is just to generate the session key. The session key that at the end of the day is generated from phase 1 by Diffie-Hellman is strengthen it and generates it based on pre-shared key and all this. Okay, the same session key is used now on phase 2 to do what?
No, it will be not used in the phase 2. That is why PFS is used. We are forcing it to generate a new shared key in the phase 2.
Okay, but the session key that is generated on phase 1, what is it used for?
That will be used in the phase 1 negotiation.
No, because okay. Okay, go ahead, sir. Go ahead. Let me just follow. Go ahead.
Okay, fine. Okay, so this was something from the overview, the parameters that we would be discussing once we start with the labs. Do you guys know the modes, different modes, let's say in the IK version 1, or let's say in the IPsec? Okay, so I'll just brief but we can discuss this much more in the next class. So IK version 1 will have two different mode. One is called aggressive mode and main mode. So this comprises of like uh, two rounds. It might be like 4 packets. Okay. Or I can say, yeah, 2 rounds. Yeah, 2 rounds. Whereas this comprises of, let's say, 3 rounds of exchanges. Total like 6 packets. To someone who is not understanding, say, for example, this is branch A, this is B. He's a initiator, he's a responder. So let's say the initiation happens, right? So some initiation happens over on a UDP. Now, which would comprise of certain parameters from here. It would be a hash value, it would be a, let's say, encryption value, etc. And from the other side, the next message comes upon. So I would call this as, let's say, message 1. This would be my message 2. Now this is a set of one complete round. So in this way, I have 3 rounds in the case of main mode. So let's say message 1, message 2. Once again, the next set of messages is being carried, which I would label as message 3. Now the responder will return back with message 4. Now what would be this? This is next round of message exchange. And finally, we will see message 5 and message 6. So altogether, how many messages? 1, 2, 3, 4, 5, and 6. Total 6 messages in the main mode. It's bit gonna be more resource consumption when compared with AM, because AM is much quicker but less secure when compared to MM. If you're not looking for a site-to-site VPN, but you're looking for, let's say, just a VPN connectivity to reach to an server, and you don't need always a fractional of additional seconds for that 6 messages, then AM is something which you can take upon. So AM will give you a faster mode of exchange of the message, and it needs only 2 rounds. So within 2 rounds, you would be passing on all the parameters, but it makes you bit complicated during the troubleshooting. You would not get to the core concept, what is getting failed or what is not getting matched up. Whereas in MM, it's much more in a split up mode. So if you are stuck at message, let's say for some reason you're stuck at message uh, 3 or 4, which was one set of round, you will go and quickly check if the things are good with this particular messages, or the parameters are matched up or not. Similar way, let's say you are stuck at somewhere 5 and 6, you will go and check if the uh, pre-shared keys that you have defined is matching up or not, or if your defined a parameter is matched up or not. But in the case of AM, since you're sending multiple parameters just to speed up the process, the troubleshooting becomes bit difficult. But again, it's part of your design which one you need it. Sometimes the design itself asks you for AM, sometimes it can ask you for MM. So depending upon that, we have to configure it. Okay. So more specific about what is getting exchanged, what happens in 2, 3, 4, we will do it in a separate class where we will discuss about the each messages and each parameter that is being exchanged. We have so many parameters, right? That is what put up here. not all of them are carried upon in a single message. They are being split into different messages. So we have to know what is message 1 carrying upon, what is message 3 carrying upon, what is message 5 carrying upon. And the responder is also responding back to those parameter itself. Okay, so
Sorry. So are
yeah.
we going to discuss all these messages through the debugging live traffic on lab?
Yes, that will come in the technical lab, but in the theory also we will be discussing this.
Okay, that's good. Okay, thank you.
Okay, here and one more thing that we will also discuss, IK version 1. We have something now, IK version v2. So when we talk about Flex VPN, it's made upon IK version 2 basically. Whereas when you're dealing with site to site VPN, you have that option to either go with uh, version 1 or version 2. It's your choice. But again, there are difference in that. So we have to look upon what is the difference, why to go with V2, why to avoid V1. There are a lot of differences. Okay. There's a complete different RFC for both of them. So that is something which we will also take it in the upcoming classes, because this VPN is a very broad structure. We cannot complete just in 1 hour of class. So I have to split. Might be one class I'll take all V1 related thing, the next class I'll take V2 related, then I'll be going with the IPsec. So that's how we will break up it class by class. Okay, so in a short form, for a IPsec, again 3 messages are being exchanged, where all the parameters are being exchanged, and once phase 1 and phase 2 comes up, we expect the tunnel is up. So let's say if I have phase 1 coming up, let's say this is phase 1, then I have phase 2. If both are up, then I will see my traffics are being sent across on this inside the tunnel. So this is what happens in a layman's world of VPN. Someone who is never into VPN concept, so this is where we start from, and the more we will spend time, you will be a more familiar with the VPN technology. So anyone who has never worked upon VPN any time so far, did you guys
Ye-
get a bit
Yes,
on?
yes,
Okay.
yes, yes. Myself. Can you please explain one more time what is the IPsec, how it works?
Okay. Say for example, this is a branch A in certain site. Let's say this is in Delhi, and the Delhi branch, they want to talk to the servers which is hosted on another region, which is in Bangalore. Okay, so I have to find a way where I can start communicating between each one of them over on a shared infrastructure. Now, what I do is I will discuss with the administrator of this region, and then I will propose him my proposals. I will say that for phase 1, I'm going to keep might be the integrity to be this one. I would keep let's say appreciate key concept, and this would be my key. I would be setting a lifetimer of, let's say, this second. I would be going with a DH, let's say, group of 2. So basically, I will decide my parameters, and then I will send him that I'm expecting you to do the same parameter on your VPN configuration. Now it depends what type of vendor is having. Might be I'm having ASA on my side. Might be he is having Palo Alto on his side. Okay. He might have a CLI way to open it. He might have a graphical way. Even I have a CLI or I have a ASDM way to do it. So how you configure, that's your way of dealing with it. At the end, we need to put the same parameter on both the end. They have to be matched. Once the configuration is done, we set up a call and we try to initiate some test packet. So I will be pushing out some test packet. I can do a simple ping or I can do a simple telnet to force my packet to get entered to this. Now, at the time of that first initiation, there will be phase one coming up into picture. And phase one is what we discussed, some of the parameters, that these are some of the parameters that we would be dealing with, etc., etc. And depending upon what version you're using, version 1, you have you have AM or V2. Depending upon that, the messages will start exchanging. You have message 1 being sent, you would be receiving a message 2, you will send message 3, message 4. After the completion of 6 messages, you will see that your phase one has been up now. So you will see that phase one comes up. In the debug, you will see the message called phase one is up or completed. Then what happens when the test packet, let's say you have sent 100 packet. You don't need 100 packet to come up. Might be, let's say you took initial 3 to 5 packets to bring up phase one. Let's say 10 packets you took to bring up phase one. Then the next packet will be used to bring up your phase 2. This is all happening back to back automatically. Your intervention is not required. This is how it is designed. The phase 2 will negotiate whatever parameters you configured on phase 2, that is IPsec, it will be matched. If the things are up, you will receive a message that phase 2 or IPsec is up, and then you can see the data being sent across on this. And with certain CLI commands or with certain graphical interface, you will see the packets. Let's say you sent 100 packet, they are getting encapsulated, and on the other side you will see those 100 packets being getting decapsulated. So that means you are, whatever you are sending, you're receiving reply back to those different packets here. So this is from the troubleshooting point of view. Sometimes what happen, you would be sending 100 packet, but the decaps would be showing as 0. That could be a layer 2, layer 3 issue, that it's unaware to follow back the return packet. In that case, we advise them to check their routing, or a switching issue could be that the packet are unaware to reach back to the the VPN termination point. That's a TS point. But to answer your question, this is how the overview looks like for a site-to-site VPN.
Thank you, brother. Thank you very much.
All right, so guys, if you have any question, you can let me know. Otherwise, I'll once take just quick 2 to 5 minutes to talk about that welcome kit. So you guys have received the welcome kit. I believe you have already received it, and my backend team had pinged you one-to-one as well to check and respond back. So I believe it's done. So within this welcome kit, you will find the access to the portal. So this is where all the recording of the live classes would be kept. And also here you would find a class 0, which is basically a Google Drive link. So whatever related to the VPN module, the notes or any CLI command or the workbook, they all will be found here. Okay. So down the line, you will see this getting updated. And apart from that, you will have a remote lab access, which is a public IP, and with certain port number, you have your own credentials. So you can start practicing once we have started with the lab. The same remote lab access, in case if you want it on a home lab, make sure you have at least 16 GB plus or 16 and minimum 6 core CPU. Then you can opt for home lab as well. So whatever we have on a remote lab, which is valid for, let's say within the package you have for a 1 year validity. But again, someone who needs on a home lab, make sure you have this resources and my backend team will help you to deploy on the home lab. Okay, so this is something which is part of that welcome kit. Workbook, reading notes, etc., will be stored up in the web portal, which is a lifetime access to you guys. The videos are non-downloadable, but it's a lifetime access. Whereas the content within the G drive are downloadable, and you can download and keep it in your local drive. If you lose in future, you can come back and anytime take it back from here. Remote lab is valid for 1 year. Home lab, since it's be installed or deployed in your own home lab, just make sure you have enough resource to power them on. Otherwise, it will not make sense to install it on a 8 GB or something. That will not work. Yes. So, any question? So, are you clear with the things that we covered up today?
Yes.
All right. Okay. All right. So I'm disconnecting, wrapping the session now, and we'll meet tomorrow at same time.
Just quick one. Now we have access to the lab and the recording as well. So as of now, I can't see anything on the lab. I think going forward we'll be able to see it, isn't it?
Yes, the lab might be visible blank right now. We will in the backend put the needful lab topology. Once we start with the technology lab, we will put that in the backend.
Okay. Yeah. No problem.
Do we have, please, do we
Sagar,
have like,
good evening.
Yeah,
good evening.
yes.
Go ahead.
Good evening. Can you hear me?
Yeah, yes.
I just joined. What happened? I was little 5 minutes late.
Actually, we are done with today's class. It started 7:30 here in India.
Oh, it's
Yeah.
7:30 p.m.
Yes.
Okay, so I can see the recordings.
Yes. I will help you with the recording part. Okay.
Oh, okay. I thought it is 9 p.m. India.
Actually, it was changed and it was notified in the group. Might be overlooked on that.
Okay.
Okay, so excuse me.
Yeah.
I wanted just to ask if we have a kind of workbook for the lab.
Yes, it is getting prepared right now. So I'll be sharing you the workbook as well in the G drive. Okay.
Okay. Thanks.
This initially there was 2 sessions, right, regarding the CCIE.
Sorry, come again regarding?
Initially you kept 2 sessions, right? 2 free sessions.
Yes, correct. Yes.
So whether we need to go through that videos or only today's?
Not needed. Today's video you better go through.
Yeah, okay. So today's topic was the VPN, right?
Yes. Introduction to VPN.
Yeah, so that labs can we able to do that related to VPN?
No, today we have not discussed anything about lab. We are just discussing about the concept only.
Okay, fine.
Okay.
All
right. Have a nice day and take care, guys.
Yeah, I can. You will be texting in the WhatsApp group regarding
Thank you, sir. Same to you. Thank you, guys.
Thank you. Cheers.